Okay, good morning, everyone. Welcome to another Gensco Quick Hitter, a series of detailed trainings on a particular topic that Gensco has been doing now for another year and a half, maybe 2 years. Put on by the DSGs of Gensco, the Mitsubishi tech support team that works on the outside with the sales teams. Today, we're going to talk about compressor failures, how to diagnose that it has failed, reasons and causations for the failure, and some of the things you need to do at the end when you're going to replace the compressor, or even if you decided to replace the equipment, what should be checked before you move onward. Now, let me allow a few more people. Okay. So, to start off, we will talk about compressor failures, symptoms that you will see when the compressor has failed, troubleshooting possible causes of the compressor failure. And someone wrote this little term I saw this past fall: compressors don't fail, they are murdered. And it's fairly true. They generally don't have manufacturing defects that will cause them to fail. It's all about the job itself. Something in the job has caused it to fail. The vast majority of the compressors you are going to encounter on the Mitsubishi M&P side will be the dual vane rotary compressor. You can identify this very easily by looking at the image on the left side of the screen here and seeing that there are two pipes that come out the bottom of what appears to be an accumulator and go into the side of the compressor. Those take suction gas from the suction line directly into the compression chamber, which is at the bottom of this compressor. You can see on the right-hand image a cutaway view of the same compressor with the two compression chambers at the bottom. Let me see if I get my highlighter working here. Spotlight. Right there. I got a little arrow going here. Here's one compression chamber, the upper and the lower compression chamber in this dual rotary compressor. The suction line comes in here and here into these two chambers. The second compressor you may run into are the frame compliant scroll compressors. Every unit in the M&P world up to 36,000 BTUs will have the dual vane rotary compressor. Anything higher than that, a 42,000 PUZ, for instance, or any of the smart multi-units, and that includes the SM36, which is actually a 48K compressor. The exception to bigger than 36 would be the 5C42 ported type multi-zone unit, which is also a rotary compressor. We'll start off talking about mechanical failures. As you see in this picture, that was pretty catastrophic failure. The most common mechanical failures can be subtle in nature, such as no compression, or they can be catastrophic, locked rotor, noise or vibration. There may be, and that would be subtle, a little bit of vibration because it's out of balance due to wear. Probably the most common one you're going to run into is the locked rotor when in a mechanical failure. The symptom of a locked rotor compressor would be that you walk up to the unit, you have the unit on to run, the unit starts to run, the outdoor fan comes on, and after about 5 or 6 seconds, the unit shuts off. It's the most common symptom of a locked rotor compressor. You may have an overamp condition indicated in the flash codes on the unit or on the unit display or even on the thermostat, or even the indoor head if it's a wall head flashing an error code. You look up the actual error code and find out it's an overamp condition due to the locked rotor. To see this locked rotor condition, you would wait for another cycle of the unit, have your amp clamp on the compressor wires during the startup sequence. The fan starts, and 5 seconds after the fan starts, and this is true for every Mitsubishi M&P unit, the compressor will try to run at the 5-second mark. You will see some kind of, if it is locked rotor, you will see an amperage that is close to the run load rating on the nameplate. If that's 8 amps, 12 amps, or whatever, you will see something very high like that for about 1 second. It won't last long. The unit's going to detect that it's overamping and stop outputting voltage to the compressor. Before condemning the compressor, you must perform a balanced voltage test to verify that the compressor is receiving balanced 3-phase power. After all, it is a 3-phase motor, and it requires 3 phases of power for it to actually turn. If you're only getting 2 of those phases, it's just going to sit there, locked rotor. The most common cause of a locked rotor is a loss of lubrication or a broken compression component, such as one of the scroll pieces has broken off and is now jamming the scroll section, or debris migrating into the compressor, preventing it from turning. The second failure type could be a no compression symptom. Unit runs, but there's no compression. Both your high and low side gauges are reading identical, or they're reading close to identical. If it's the rotary type compressor, the reason for this would be the slide vane stuck in its recess, or the discharge reed valve has broken off. Scroll compressor has a broken crank or a discharge reed valve broken off, or it could be running backwards. Scroll compressors do not pump if they run backwards. And while it does not matter how you phase the power coming into any Mitsubishi unit, including our 3-phase commercial equipment, if you wire the compressor backwards, it will run backwards. So if it's running backwards, the most common cause of that is someone has done a repair on the unit and failed to maintain the proper wire connections, either at the board or at the compressor. It's characterized by very low amperage. In the case of a stuck-in slide vane and a dual rotary compressor, the amp draw while it is spinning will be less than 1 amp. And it's the way you can tell the difference between a stuck slide vane in a compressor caused no compression or a stuck reversing valve being halfway. It'll also cause no compression, but you're still moving refrigerant through the compressor, and the amp draw will be somewhat normal in that case. Now, this is caused by a loss of lubrication or liquid slugging of the compressor, causing damage. This is an image of the lower compression chamber of that dual rotary compressor. You can see I have marked the discharge port. In this case, there's another plate that sits on top of this or underneath it because this is the bottom. And it discharges through the reed valve, which you'll see a picture of shortly, into the compression, into the shell of the compressor. The suction line comes in from that accumulator on the side of the unit directly into the compression chamber. In the image on the left, you can see the slide vane is recessed and pushed by the roller into its recess, which has a spring on the back side. You can see in the other slide on the other side of the page. In this frame, the roller is on the opposite side of the compression chamber, and the slide vane has slid out of its roller, making contact out of its recess, making contact with the roller and maintaining compression on the high side. So this rotates in a clockwise rotation on this side, and on the upper side, it's counterclockwise rotation. relative to the roller and shaft. That is the slide vane. That is the roller. That is the shaft. Here is the compression chamber. This is the cam that the roller rides on. You see that it puts the roller off center of the shaft so that it can wobble around inside the compression chamber, and with the slide vane, produce compression. And the oil pump, you can see the two little vanes that pick up oil from the bottom of the compressor to distribute it to the oil ports in the moving parts section, such as where the cam comes in contact with the roller and the shaft comes in contact with the bearings. This is the slide vane that would be above that discharge exit from the compression chamber. Another failure, the more subtle type, would be a noisy compressor or one that is vibrating badly. The unit runs, but it's either very noisy or it vibrates a lot. It's due to wear of bearing surfaces, or a compression component has broken off and has thrown the rotation out of balance. Metal on metal noise may be present, caused by a loss of lubrication or silica contamination. This is what bearing wear looks like. If I can get that out of there, it go away. Bearing wear on the shaft. See how it's got grooves in it. This was determined by the factory to be caused by silica, sand, some kind of contaminated construction debris. It could be the stuff that comes off your sandpaper that got in the piping, did not get caught, made its way into the compressor, and is now sandblasting and grinding away at the bearing surfaces. Metallic debris from this wear and collect in the bottom of the compressor. There is a small magnet at the bottom of the compressor here. You can see where it has collected steel components. The brass and copper pieces won't stick to the magnet, of course, but you can see how the magnet has collected a lot of steel debris down there. This is a pretty bad worn compressor when you find this kind of stuff. How many of you guys are aware, I hope you all are, that you must heat these compressors up before you turn them on, especially the first time? It requires 12 hours of power before running so that the crankcase heat function, which is a function of the inverter, heating the windings of the compressor in order to heat it up. If we do not have the oil preheated and no refrigerant in the oil before we start, we could have any liquid that's in that oil come out of saturation, turn into a gas when the sump changes pressure, foam the oil, and the compressor pump all the oil out. Once the oil is out of the compressor, which can happen, guys, in as fast as 5 seconds, there's no lubrication on the bearing, especially the bottom bearing. It's going to take about an hour of runtime for that oil to come back to the compressor. So the first start is the most important. Most compressor failures can be traced to that very first start and damage that occurred on it due to this reason. It's called a flooded start. Now, all MXZ units have the preheat function enabled, and all P series have the preheat function enabled. The ones you have to worry about are the M series one-to-one systems. In that line, only the SUZ, KA2430 and 36, 5 got in there, 36 hyperheat units have it enabled because those units are actually P series hyperheat units. The other M series one-to-one units, this function must be enabled by cutting a small wire jumper on the control PC board, which is labeled JK. You'll find it on the control board, and this is going to be in the units that only have one board. The small SUZs, even the hyperheat SUZs under 24,000, any M series MUZ or MUY that has the one board function, you have to look for this JK jumper prior to turning power on and cut that jumper. If the jumper is not there, and there are a handful of units, and the only ones I'm sure of don't have this were the GL24, the FH15 and 18, and I am not 100% sure of any other unit having the jumper removed and that function enabled, but those three units I am sure of. I don't think it's enabled in the GS24 until I see one to verify that. I can't be sure. So if you're doing an M series unit, MUY, MUZ, SUZ, you must look at this board prior to powering up and find these little jumpers on the board. And if that JK is there, as shown here, it's a small wire jumper. Take a little small snip and snip that. Bend it out of the way so it can't make contact. And the crankcase heater will be enabled. You now have to have power on without the unit running for a minimum of 12 hours. If you can't wait 12 hours, you could put a heat gun to the bottom of the compressor and begin heating it. And Mitsubishi has actually tested how long that would take to adequately heat the oil in a compressor. And they came back with 2.5 hours of heat gun. And again, the first time you run this unit is the most important moment in its entire existence. So this is a huge, huge thing in our world that we want to see done before you start compressors. Mechanical failures, loss of lubrication is the overwhelming reason for the mechanical failures. That could be due to a flooded start, or it could be due to liquid flood back while it's operating, which would be caused by malfunctioning expansion valves, overfeeding refrigerant, or lack of airflow over the evaporator coil, which would eliminate any superheat coming back to the compressor. And it's also caused by silica-based debris scarring the lubricated surfaces. So how does silica get in there? I went to look at a job site a couple of months ago on a new install. And as I walk around the building, I see the 3 lines coming out for the 3C30 that was going to be in the building. And 2 of the line sets were stuck in the mud. The only line set not stuck in the mud did not even have tape over the open end of it. Well, that kind of stuff is happening out there in the field. We don't get to see every job, but some of the ones I have seen, I have to wonder, how many times is that actually happening where you're in a hurry, you're not paying attention, it's Friday afternoon, and we left for the weekend and forgot to seal up our pipes. So that's the kind of things that can cause debris to get in the system in the first place. Now we'll talk about electrical failures. Obviously, this one looks pretty bad. Types of electrical failures: shorted to ground, most common failure. An open winding, not really common. Unbalanced resistance between phase windings. And to point out, 80% of compressor electrical failures were actually caused by mechanical damage that progressed to the motor failure. Excuse me. I've got a link here to a document that describes different ways that compressors fail and some of the leading causes of it. Someone wants to take a picture of that, they can go look that up themselves. I'll wait a minute and give anyone a chance who wants to do that. Okay, so I have a couple of questions. One is, what if you lose power for a couple of days? Should you wait for it to be reheated? The answer is yes. refrigerant migration will occur anytime that the temperature at the outdoor unit is lower than the temperature inside the house. And we all live in the Northwest, and I'm sorry, but that's going to take place for about 8 months out of the year, where outside is colder than the inside of the house. The only few places in the country I can think of where you may not worry about this is Miami or Key West. And another question was, why is the JK not cut from the factory? Efficiency ratings. It's going to steal power. In the case of some of the units, it could be 50 watts of power is used to crankcase heat that compressor. So that can have a significant effect, 50 watts when a unit's not running, on its overall efficiency rating. And we want to be able to sell this unit based on its efficiency rating. So that is why it's not cut from the factory. Now, when it gets to the homeowner care if his efficiency went down slightly, not if it keeps his compressor running. Well, that is why it's not cut from the factory. So shorted to ground. Insulation on the windings has failed, and voltage can flow direct from one of the phases to the compressor shell and then to ground, or winding to winding resistance less than 500,000 ohms, which could be caused by liquid refrigerant saturated oil laying on the windings. That's why you have to heat it up. If you actually look in the install manual for a lot of the units, it will tell you to meg ohm the compressor before running. And if the resistance is less than 1 million ohms, to heat the compressor again and meg ohm test the compressor. It's actually in the install manual. You have to heat the compressor enough to get the shell to stay 20 to 40 degrees above ambient temperature when the heat is removed. If any of you guys have the maintenance tool, if it's a smart multi, the city multi maintenance tool, and if it's an M or P unit, the M&P type maintenance interface, you can look and see what the discharge temp is reading on the compressor. And I call it good to go if that discharge temp is at least 15 degrees higher than ambient air. It's taken a little while for that compressor to heat up enough to get that sensor to that level. So if you see the discharge line, or you can measure it with an amp clamp, if it, without, again, applying your own heat to it, if it's reading at least 15 degrees above ambient, it's ready to go. So shorted to ground is going to be when the resistance is very low. Usually it's, when you measure it, it's a single number or it's a kilo ohm range. The compressor has failed. The short could be from metallic debris embedded in the windings and bridging the gap to the housing or filling gaps between phases in the windings. It is rare for a short to be caused by a power-related issue, as part of the inverter function is to protect against incoming issues. Now, in this attached photo, this is an actual unit I cut apart 2 years ago. Only one of those 9 segments is shorted to ground. Can any of you tell which one it is? I'm going to go with no because they all look pretty bad. This is what the same compressor looks like good. This came out of a good, clean compressor. You can see the 3-phase wires connecting to 3 of the posts, and each of those are connected to 2 other posts, giving us a total of 9 segments, 3 per phase. And that preceding slide, the one that was pretty nasty, that was actually caused by water contamination. If moisture is in the system, it can lead to acid formation, and it will reduce the insulation value on the windings by taking the insulation off. And it's breakdown of the insulation due to moisture is the next leading cause of electrical failure outside of mechanical debris or damage causing it. The inverter has a function which can detect a short and not actually allow the unit to operate. This would be one of the reasons why you generally never find the breaker tripped in the power panel when a Mitsubishi compressor has failed electrically, because the inverter can see that and it will not let the unit run. So if you go to a unit, a house, a home, a business, and you start the unit and it doesn't even try to run, you just start getting an overamp error code, and the outdoor fan hasn't even tried to run. That is because the inverter has detected it. I'm going to show you a little video here of the inverter in action. This is on a smart multi-unit in our training center. I connected this Refco inverter checker to the output of the board. And you're going to see this inverter perform two basic functions other than running the compressor, which it will do at the end. The very first function that it's going to perform is to look for a short to ground. This is going to happen real fast. You have to be watching the screen. You're going to see 3 of those lights blink on and off extremely fast. That's the inverter looking for a short to ground. When it puts that quick pulse of voltage to the compressor winding, if it sees current draw, it knows there's a short to ground and it will not output any voltage any further. If it passes that test and it does not see a short to ground, then you're going to see the inverter looking for the south pole in the rotor. And I say rotor because our rotors inside of a Mitsubishi inverter-driven compressor is already a magnet. That's why we can turn compressors at various speeds and with as little as 10 volts applied to it. So look for these 2 things. You're going to see a very brief blink of the lights, checking for short to ground. You're going to see it looking for south pole. The lights will rotate in a rotation pattern. And then you'll see it actually fire up and run the compressor. On the left-hand side, you can see the display in this unit, and I have set the dip switches on SW1 to show me the target compressor speed. So as soon as that says 22, you're going to see these lights blink. So here we go. So I'm going to do it one more time. It's very fast at the beginning. You're going to hear a click. Lights are going to blink. Short for ground. Then they rotate around and around looking for south pole. And then it runs. You saw that quick blink? That's why we don't blow breakers in panels. We detect a short to ground before we run the unit or try to run the unit. Now this would be a balanced voltage check. All 6 of those lights are lit. All 6 IGBTs in the inverter are firing. And we are producing 3-phase power. Now this is an example of a slot short due to mechanical wear. If you look at the inside of the stator, you will see that the bottom looks fairly smooth, and as we get close to the top, it's grooved. The rotor has been rubbing on this. It filled the gap with metallic debris, and there was an electrical bridge made. And you can see the burn marks there. Now, another failure would be an open winding. This is a very uncommon failure. This would require one of those internal phase wires to break or come off of its terminals. Remember the photograph that showed the good winding and all the wires that connect it? This would be one reason why you may have an open winding. One of those wires is actually burned off or broken. An unbalanced resistance between the windings. Again, this is going to be very uncommon. It's likely caused for the same reason as an open winding. One of those connecting wires between the phase coils has broken, and now when we measure resistance, we're only reading 2 of the windings 2 of the coils instead of 3, or 1 instead of 3. A separate possibility could be unbalanced voltage. the unbalanced current will be 6 to 10 times higher than the voltage unbalance, and this could cause excessive heating of one of the windings, which could alter its resistance. This is where the balanced voltage test comes in, where we want to see all three phases feeding the compressor pretty close to the same number. We would like to see like 152, 151, 150. That's pretty balanced. But if we see 152, 151, 137, not balanced. And of course, if we see something like 152, 151, and 21, it's not going to run. That's going to single phase the motor and it won't start. And do not ever rule out that a refrigeration issue was the root cause of the electrical failure. Every electrical failure usually has its roots in a mechanical issue. Anytime you have a failed compressor, whether you're going to replace the compressor or it's an older unit and you're going to replace the unit, or even if it's a new unit, you're going to replace the unit, and it happens. The proper procedure is to pull the compressor out and drill a hole in it if it's the dual rotary compressor near the bottom corner edge. You can't tip it over and pour it out of the discharge line. It's not going to come out. It's not going to come out of the suction line. You have to drill a hole in the bottom of it. You have to catch it in something that you can measure, and you have to look at the quality of it. What does it look like? If it was an electrical failure, you're going to want to acid test that. Not all electrical failures in systems that use POE or PVE oil will produce acid. It requires moisture to be present for that to occur. You may have an electrical failure in a good dry system where the compressor shorted to ground and the oil may even be dark, but it may not be acidic if there's no water of it available for that to form. So once you have decided to do that, you need, okay, how much oil did I get out of the compressor? How do I know how much is in the compressor? One place where you can find that is either the unit submittal or service manual or the engineering guide. But be careful when you go here. And that is the only acid test kit you should ever be using, one that is two-part, not those little quick tests that you just stick on the Schrader core. Those are not accurate. So this is where you could find how much oil is in a system. This is, you see the upper one from a Smart Multi 42 from the service manual. It has 78 ounces or 2.3 liters of oil. Now, if it is a scroll compressor, you're going to have to drill a hole in it still. The older scrolls, you could tip them over and drain it out of the suction line. The newer scrolls, you cannot. It won't come out. So you have to drill a hole in the bottom, drain the oil in something you can catch it with that can also measure it. And we're looking for something close to this number. Here I have an MUZ FS18, and it can be conflicting information. The upper line came from the submittal. It says ounces and then says 0.40. My question would be, is that 0.4 ounces or 40 ounces? And they put a decimal in there. That 40, as you see from the service manual in the line below that, is actually 0.4 liters, which is 13.5 ounces. And then the GS12 at the bottom from the service manual again, 11.8 ounces or 0.35 liters. So that's the kind of oil you should be getting out of these compressors. And if you get nothing, then that oil is still out in the system. And if that oil is still in the system, especially that Smart Multi with 78 ounces, if you just put a new compressor in there, which is going to get you a new 78-ounce oil charge, now you have 156 ounces in the system. That could lead to another failure. The odds of you losing a second compressor after you lose one go up 400% from a brand new unit failure rate. The oil in the jar on the left is brand new oil. You can see it's pretty much looks like water, crystal clear. The one in the middle, this came out of the same unit that had, I showed the ugly, nasty windings in. That one was described as having green slime coming out of it. It was from water damage. Water actually in that unit caused that. And of course, the oil on the right, that's a burnt compressor. But the oil should look like the one on the left. The major causes of compressor failure is, of course, moisture due to improper evacuation, wearing down, causing acid and wearing down the insulation. A lack of lubrication could be due to bad piping practices, or your homeowner has not changed his filter in 2 years. Debris, copper filings from deburring copper, sand, dirt, construction dust, sheetrock dust, iron oxide from emery cloth, etc., something from the installation process. And these major reasons have been determined from detailed analysis of compressor failures from compressors the factory asked for back by their engineers, who actually tore them down and did detailed analysis of what caused the failure. They can tell the difference between silica wear on the bearing and lack of lubrication on the bearing. It has a different pattern when it wears the bearing. So keep it clean, keep it tight, and keep it dry. And now we'll have a question session if anyone has any questions. And I still got some latecomers. Let me click them. Wow, we got a lot. Good turnout here. Okay. Anyone have any questions?
Hey, sorry, Rick, I cannot see the chat questions.
You
So
can't see the chat questions?
I cannot. I saw your response.
You know,
But-
probably because you signed in as an attendee and not the panelist.
Yeah, that's all right. You got it covered. So
Yeah, thank you.
yes,
We're gonna need to get them into the cart today.
As far as, once with the compressor fails and Mitsubishi Gensko requires us to hold them for that set time, they have an issue with us popping a hole in the bottom of that compressor for checking for acid contamination.
Not at all. We want that done. The only reason they ask you to hold it is in the event, for some reason, the factory asks for it back. Maybe they want us to tear it down. But they don't need to see the oil if you've already taken it out of there. They're gonna just be looking at the mechanical parts.
Is there a particular place to drill the compressor?
Obviously, not right in the very bottom, but where I do it is where the bottom starts to curve up to the side of the compressor in that arc, about in the middle of the arc. That's where I drill a hole. So I can tip it to the side, catch all the oil that's in there, and let it drain out.
Okay, thank you.
You're welcome.
The new GS models have a compressor protector component on them that the GL and the FSs do not. Are you familiar with this component, and do you know what ranges it operates in?
I believe that's like a snap action temperature disc. I have yet to see one physically. So I can't tell you 100% exactly what it's going to work at yet. David, do you have any idea?
yeah, Anthony, I've checked. I have not. I got a response back on that. So still digging for some type of information. So I will work on it.
No worries. I appreciate you guys.
Yeah, you bet. No, I want to know too. I agree. So
Well, obviously something happened that caused them to say, hey, we need a little bit more protection here. Let's add a new component.
Exactly. I was kind of curious about the backstory to that, but
You know, that's one of the things, unfortunately, we will probably never know the answer to, the exact reason why. They keep that kind of stuff pretty tight to their vest, and I don't blame them. You know, there's competition out there and everybody's trying to steal each other's ideas.
Yeah, I don't know if I can't see it being the same rating as discharge temperature. You know, maybe the rating on it is lower. I don't know, it'd be interesting to find out the range, right? So,
Right. We'll find out eventually, and we'll be talking about it in our training sessions. Another question is, what would cause a lack of oil return? That is a good question. That could be short cycling, number one. If the unit is extremely oversized and short cycles excessively, oil leaves the compressor with each startup, and it takes an extended runtime to get that oil to come back. Or it could be bad piping, wrong sized piping. Another major cause would be the pipe is too big. We don't have the velocity that we're trying to get to bring that oil back. It could be because it's caught in an oil trap somewhere. Could be another reason for it not coming back. And what is the procedure to clean the system after a compressor burnout? You know, it's a dice roll. Depends on how bad it is and how much oil you got out of it. If you didn't get any oil out of the compressor, if it's all out in the system, you're going to try to at least flush the line set in the indoor head. Flush that to get anything that may be in there. In the case of especially the smart multi-type units or P series that have those big accumulators, any oil that's in there, you're not going to get it out, not without running the unit or changing the accumulator. So if you had a unit that had a smart multi and had no oil left in it, 78 ounces is out in the system, and you flush it and you don't get any oil out of the lines or the indoor heads, a lot of it's probably in the accumulator. At that point, it might be change the accumulator also. We do that often on our commercial equipment. If you have more than one compressor failure, we'll have you replace the accumulator. The accumulators have an oil pickup in the bottom, so they actually do return oil. It doesn't have to fill all the way up, but that pickup is a small orifice with a strainer. If something clogs that up, then the oil doesn't come out of the accumulator. In which case, replacement is the only option. A lot of messages. Let's see, how do you remove it? Again, flushing the system. And this training is recorded and it will generally be available on Gensco Customer. A lot of the trainings we've done in the past are on there. And A2L classes coming out all the time. They're already doing them. They've been doing them for months. So look for some of these being advertised. There's some more coming up. So what happens if you don't power the unit 12 hours before the first start? Again, that's going to be 12 hours is what the factory wants. Now, if it's warm outside, it's summertime and it's 75 degrees, it may not actually crankcase heat above that temperature. There is a certain point where it will not crankcase heat. It doesn't feel like it needs to. But if it's 30 outside, 12 hours of crankcase heating. If we don't, then a refrigerant will migrate to the oil. Everyone in the HVAC industry at one point has heard that term, refrigerant migration. It migrates to the oil even without a pressure difference in the system, because the pressure of the refrigerant in the system, static pressure, maybe 100, 140 PSI, but the vapor pressure of the oil is only 20 microns. So refrigerant will migrate to the oil and continue migrating to the oil until the oil can't hold anymore, at which point it's saturated. When you start the compressor up, that saturated refrigerant turns into a gas, and foams the oil. If anyone has ever worked on commercial semi-hermetic compressors with an oil sight glass, you probably have experienced a flooded start or seen one where the oil level in the sight glass is at its level, half or 2/3 up the glass. You turn the compressor on, it turns into a big foamy mass in the sight glass. And then when the foam is gone, so is the oil. And you can't see it with a flashlight. Where the hell did it go? Crankcase heater was bad. The unit had a flooded start and all the oil turned to foam and pumped itself out. That is what is going to happen. And again, you don't need to have a pressure difference because the vapor pressure of the oil is just 20 microns. I think if the power is off for 3 hours or less, you don't have to worry because you're not going to have much migration take place there. And when it comes to that, again, I have had this argument from some techs in the field. Well, I got the unit sitting here on the side of the house. The sun's been shining on it all day and it's all warmed up. Well, yeah, it warmed up the coil, but the compressor has a blanket around it. It didn't get warmed up, and the sun shining on the unit sitting there actually made it worse because it heated up the refrigerant in the coil, and it then migrated to the cold compressor. Now, in a perfect world, yeah, again, that's what we're looking for, compressor pre-warmed. Right now, we're doing inverter-driven crankcase heating, and it's not the same in every unit. For instance, my FH15 unit I have, it is a 30-minute on, 30-minute off cycle when the compressor is not running, and it draws 50 watts. I have an FS6, it's 18 minutes on, and it's 100 minutes off cycle. And some of the other units, like the Smart Multi or P-Series units, seem to be continuous for a minute or two. One winding for a minute, then another winding for a minute, and it's not very much wattage, 15 to 12 watts continuously. So it's different in each unit, and what's published in the book is just generic, but we continue to test and come up with our own answers in many cases. Any other questions? Now, if you have a compressor failure and you're going to change the compressor, okay, good question. Do you have to preheat it? Provided you have it liquid charge that thing through the charge port, all the 8 pounds that goes in it. But if you did that, and I'm going to caution you against that, where it says charge port, that's for adding a little refrigerant while it's running, not when the unit's off. And I've had guys who actually did that. They put all 5 pounds in the charge port and then 5 minutes later turn the unit on, and they got a locked rotor condition. The entire compression chamber was full of liquid refrigerant. And damage occurred. So in order to not have to do the preheating, myself, this is my procedure. I just put 8 to 10 ounces of refrigerant in the system to get pressure in it. And then I turn the unit on and I slowly trickle charge the rest of it in cool mode in the suction line. That's how I charge units. Some guys will put all the liquid in the liquid line if it has a liquid line service valve and let it take as much as it can. The compressor is going to push it in the other direction, but do I have time for that liquid to not come back as liquid? Does it have time to go through the coil and not come back as liquid and wash my oil out? Does preheat need to happen before or after the pump down? If you're pumping the unit down and it's been off, yes. If you are, I say pump down. Are you recovering the charge? No. But when you recover charge, if you are recovering charge for something, you want to make sure that you got all the refrigerant out of the oil. Anyone who's done this for a while has found instances where you vacuum, your recovery machine goes into a vacuum, you turn the unit off, and then you think, oh, I got all the refrigerant out of it. And I've had a lot of guys say, you know, I left it sitting there overnight and I came back the next day and I had 40 PSI of pressure in the system again because there was so much refrigerant in the oil that worked its way out. It takes a long time to do that unless you're heating it. And if you're in heating mode, same thing, whether you're heating or cooling, it works the same way. Brand new startup on evacuation. You're evacuating your line sets, not the compressor at that point, I hope. But you want to preheat the compressor once you have it ready to go, or even before you have it ready to go. You know, you could hook up, power is available. You could hook power up to the unit, L1, L2, and turn the power on. It'll start crankcase heating right away. You don't have to have anything else connected to the system. The ball valves will still be shut and the compressor begins to crankcase heat. Charging and heating mode. If you have two ports on the outside of the unit in heating mode, they're going to be high pressure. So you're not going to be able to charge it that way. You could charge it directly into the charging port, but it's very slowly done, trickle charging it. Or you could put it in cool mode. If it's a ductless unit, one press of the emergency out button on the indoor head puts it into cooling mode, and you have 30 minutes where it will not care what the temperature is, it'll just run. There's no way to force on the crankcase heater. And at what temperature does it shut off? It depends on the unit. Some of them do shut off. Some of them just change their pattern, like my FH at 72-degree ambient. Instead of 30 minutes on and 30 minutes off cycle, it goes to a 15-minute on, 30-minute off cycle. But I don't know what the algorithm is for every possible unit out there. I know they're different in different units. And a way to force the crankcase heater, again, no. Now, we have been doing crankcase heating with the inverter for a long time, but that's about to change when the new A2L refrigerant units come out. They're going back to a belly band type heater on these compressors. And you could always take your own heater and wrap around the compressor another belly band or tie it to power while you're installing to get it going faster. Or you could put a heated blanket around it, or you could do something to add extra heat to it. Just do not use an open flame, guys. We don't warrant units that caught on fire. You could preheat it in the shop if you have a way to do that. I've actually got a contractor, and I tried to test this in our training room, but it's not field conditions, and the temperature in the room is like 72 degrees. With just plugging 110 volts to the unit. The inverter doesn't care what voltage you stick to it. It'll output voltage to the compressor. So I need to do another test on a unit with 110 volts plugged in an outlet tied to L1, L2, and verify that it actually will heat the compressor and how long. And one of the ways you can tell your compressor is ready to go is, again, if you have the maintenance tool and the maintenance tool software where you can see the actual discharge temp before you get ready to run the compressor. Well, again, how do I see that? You can see it with the maintenance tool hooked up to the unit. Or you can put a temp clamp on the discharge line. That's where the temp clamp is. That's where the temp sensor is. And see if the discharge line is warm, then the compressor is warm. Of course, if you have 220 in your shop, that would do it. Hook it up the day before you go in to install the unit. Then once you get it to the site, hook the power back up and keep it going. That'd probably be a really good idea. In my view, the discharge temp should be 15 to 20 degrees higher than ambient. So if it's 40 outside, I want to see the discharge temp at 55 to 60. That's what I do when I go out for a city multi-startup on our commercial product. I hook my maintenance tool up, and then when they tell me that power's been on since last week, and I look and the discharge temp is only 2 degrees above ambient, I'm like, nope, it has not been. Because when it is, it's going to be 10 to 20 degrees higher. It may not. It's hard to tell. Some of the units, such as the Smart Multi, actually have an output on the maintenance tool that says it's crankcase heating, called preheat. Warm-up procedure with a heat gun. Don't leave it in one place. You got to move it around, so someone has to be there changing it, or you keep it far enough away that it won't actually cook the oil in one little spotted location. But again, Mitsubishi I used to tell people when I first thought of, hey, why don't I just use a heat gun for about 20 minutes? Mitsubishi said that might be a good idea because we really want it warmed up. Let's go in the factory and test this. And what they found on most M&P units, it was about 2 hours of heat gun use to get the internal mass of that compressor as warm as the external mass. Remember, you're not just heating the outside shell, you have to heat all that metal that's inside the compressor. So if you're doing it with a heat gun, it's from outside in. It's going to take a while. If you're doing it with the crankcase heater, it's just a little bit of wattage, but it's from inside out. And the main thing about the crankcase heater being on is those 1-to-1 M series units, making sure that JK jumper has been cut. And if you change a board on a unit, make sure you cut the JK jumper before you put the board in the unit. You guys have been asking good questions. Yes, Jim, I have told everyone in my training class, you get there in the morning with the job, you're going to install it. And, I know everyone's got a lot of work and they can't afford to wait and send somebody back on a separate day to start this thing up. But if power is available and you get there in the morning and you set the outdoor unit and you tie the L1, L2 and get that power turned on, now it's crankcase heating and you can go run your line set. You can get the power run to the indoor head. You can get everything mounted. You can get all that stuff done. You can clean the job up. And in the afternoon, take a temp reading on the discharge line above the compressor. And if it's warm, it's ready to go. Any bit of heat there is going to help you. Even if you don't get it all, you're helping yourself in the long run.